going to talk about the derivative of a sum. Suppose, say, h of x is a sum. It's the sum of f of x plus g of x. Possibly f of x is, I don't know, x squared or 3x squared plus g of x, which is 7. So in other words, if h of x is 4x cubed plus 7x minus 9, we can think of this as a sum or difference of 3 different functions. Now, I do want to make one slight change. Let's try to sneak in plus or minus in the same proof. Okay, so if f of x equals that, then h prime of x, well, we take the derivatives separately. F of x plus or minus g prime of x. F prime of x plus or minus g prime of x. The proof is straightforward. Definition. By definition, h prime of x is the limit as h approaches 0 of h of x plus h minus h of x over h. So this is equal to the limit as h goes to 0. Well, h of anything is f of anything plus or minus g of anything. So it is f of x plus h plus or minus g of x plus h minus h of x, which is f of x plus or minus g of x. And this all gets divided by h. And we'll combine things. This is the limit as h goes to 0 of f of x plus h minus f of x. Let's hold on to that. Plus or minus g of x plus h minus, better say plus or minus, and it does, plus or minus, oh, I already have the plus or minus in the front, so we'll say plus g of x. And all of this gets divided by h. To save a little time, we could divide both of those terms by h, and we are almost done. We just have to distribute their limit. The limit of the first term plus or minus limit of the first plus or minus the limit of the second. And there's a typo here. Let's see what's going on. So when I take away this, it'll become minus plus. Minus plus this limit we're going to prove the sum and difference formula of functions for the derivative. So for example, if I say that h of x is equal to f of x plus g of x, this would mean that h of 7 is f of 7 plus g of 7. So how about we get right into it? Theorem. If h of x is equal to a sum or a difference of two functions. So let me actually say this a bit clearer. If h of x was 7x squared minus 9x plus 4, then maybe this would be f of x and this would be g of x, and we'd even have an h of x. Let me write down the conclusion. Then h prime of x will be the derivative of the first function plus or minus the derivative of the second function, which means if you want to find the derivative of h of x, you find the derivative of that, you get what you get, minus, you find the derivative of this, you get what you get, plus the derivative of that. You take the derivatives separately. Now, I guess one other notation. When it comes to f of x plus or minus g of x, if you're gonna read the top sign, then you always read the top sign. For example, if we had plus or minus our h of x minus plus j of x. If you're gonna read the top sign, then you read the top sign. If you're gonna read the bottom one, then you always read the bottom. And as always, we do the proofs by definition. H prime of x is equal to the limit as h goes to 0 of h of x plus delta x, plus h minus, maybe in this problem I'll use delta x. And the reason is that I don't want to say h here when we have our function h. I could continue to say h goes to 0, but the function h, I should give a different name. Minus h of x all over delta x. So this is equal to the limit as delta x goes to 0. Well, f of anything, h of anything is f of the anything plus or minus g of the anything. And anything is, in this case, x plus delta x. So you get f of x plus delta x plus or minus g of x plus delta x. And from this, we're supposed to take away h of x, which is f of x plus or minus g of x. And all of this gets divided by delta x. So this is the limit as delta x goes to 0. And I'm going to combine things in a natural way. I'm going to do this minus that first, because that starts to look like the derivative of f. Minus f of x plus or minus g of x minus g of x plus delta x minus g of x. And they both have the plus minus, so it's just plus minus g of x plus delta x minus g of x. And The whole thing is over h. And now it is all coming together. Because if you have two terms divided by h, you can divide them separately by h. That is, you have the limit as delta x goes to 0 of f of x plus delta x minus f of x. I just copied this, and that gets divided by h, plus or minus this divided by h. G of x plus delta x minus g of x over h. And it's the limit of that whole thing. But the limit of a sum or difference is the difference of the limits. That is, I can distribute. It's the limit as delta x goes to 0 of this difference quotient plus or minus the limit of the second term. The limit is delta x goes to 0 of g of x plus delta x minus g of x over h. And as long as f and g are differentiable, the first limit is f prime of x plus or minus g prime of x. Now, if the plus minus bother you, I want you to go through this problem again, only reading the plus sign, only reading the top sign. Just read the top, make sure you agree with it, and then go back and read the problem with just the bottom sign, f of x minus g of x. And anytime there's two symbols, read the bottom one, which coincidentally is always minus for subtraction. Read just the bottom. That's two proofs in one. Pretty slick.